Recording in progress. In this class, we will learn about the implicit method. Okay, not always you can find your y equals to fx. So in this kind of situation, you have to do it in the implicit way. I'm going to call student to work with me together. Okay. Emily, let's go ahead to number 3. How do we do this one? Let's do the derivative for both sides, okay?
Y prime or dy over dx is equal to.
So on the left, it's y prime. Or you can see dy over dx. It's the same. And on the right, you're going to do this guy derivative. This guy derivative will be cosine xy times x derivative times y, because you have to do the chain rule. This guy derivative is cosine copied on xy times xy derivative. X derivative is 1 times y plus x times dy over dx. Does this make sense to you?
No, not really.
Not really?
No.
Oh. At the end of last class, you asked me this question. You want to do this guy derivative. This guy derivative. This guy derivative, you want to write down this as a whole thing derivative. Sine derivative is cosine, correct?
Yeah.
So cosine xy. And then you want to do xy derivative times xy derivative. Xy derivative is going to be product rule. X derivative is 1 times y plus x times y derivative, correct?
Yeah.
Okay. Your school haven't teach this part yet?
We just finished learning it today.
Okay, yeah, but this is good practice for you now. Does this make sense now?
Yeah.
You have dy over dx here and here. You do the distribution, okay? Y times cosine xy plus x times cosine xy, then dy over dx, correct?
Yeah.
And then you move this guy to the other side, okay? So you have 1 minus x times cosine xy times dy over dx equals to y times cosine xy. Are you okay for this step now?
Mm-hmm.
So dy over dx equals to y times this over 1 minus x times cosine xy. Okay?
Mm-hmm.
Does this make sense now?
Yeah.
Okay. Olivia, let's do the next question. Let's do this one. Go ahead, please.
Okay. So it's 2x
Good.
plus y plus x times dy over dx. and then
plus
equal
y plus x times dy over dx equals to 0. Very good. When x is 2, you want to plug in here, yes?
yeah.
4 plus 2y equals to 10. Y equals
3. Oh wait. I just okay.
yeah, that's right. Uh-huh.
Okay.
And then we can plug in. Go ahead.
Okay.
Two times 2 plus y plus 2 times y is given. Y is 3. We found the y already. Plus 2 times dy over dx equals 0. How much is dy over dx? How much?
-7/2.
So dy over dx, this is 7, -7 over 2. There you go. This makes sense now, right?
Yes.
Okay. Now let's do the next one. Angela, let's do number 6. They ask the slope of the line. So you want to do the implicit method. Go ahead, please.
Okay. It's 6y times dy over dx minus
6y times dy over dx
minus 4x
4x equals
equals -2 times y plus x times dy over dx.
okay. Now let's go ahead and plug in.
Okay. So then it's 12 times dy over dx minus 12 equals -2 times 2 plus 3 times dy over dx.
So that is 2 plus 3 times dy over dx, correct?
Yeah.
Okay. Now we can simplify this, okay? Yeah. We can say this is -4 minus 6 times dy over dx, right?
Yeah.
So we move this guy around to this left. That it becomes to 18 times dy over dx, right?
Yeah.
Equals how much?
Equals 8.
Equals to 8. So dy over dx equals
Equals 4 over 9.
4 over 9. There you go. Does this make sense?
Yeah, so you just find an implicit and you plug it in, right?
When they ask you the slope of the tangent line to the curve, basically you are using the implicit method to find your dy over dx. X, y was given, and then you plug in, you find the slope, okay? Next one. This one, I read down over here, it's too squishy, okay? I'm going to move this stuff into next page. So this is the real AP test. And this is AP test for calculus AB in 2008. They ask us to find the dy over dx, okay? Any volunteer who want to do this question with me together? Anybody? Nobody? Zhao Yuchen, let's try this one. We use the implicit method, okay? Go ahead.
So 2x
Plus,
2
plus,
4y cubed
times
y prime.
dy over dx
Oh,
plus
4y prime.
for y prime is same as dy over dx
Okay.
equals to 0, okay?
Mhm.
Well, we want to see this again and again. Y prime is this. If y equals to fx, you can also see y prime is same as f prime x, okay? This thing are the same thing. Next, let's find that guy and go ahead. Combine the term, go ahead. We do 2 times x plus 1 plus who?
4y cubed plus 4.
Very good. Yeah, you do very good. And then dy over dx equals you move this to the right. Yes, negative 2 times this.
Okay.
Right. 2 and 4 can be simplified, right?
Yeah.
So we will simplify it. This equals
Negative
x plus
x
1
and 2 times y cubed plus 1.
plus 2.
Okay.
Yeah. Or we can say this guy is that.
Okay.
2 and 4 canceled, and then 2 and 2, and take out 2, this becomes y cubed plus 1.
Okay.
This is exactly same as here, right? Does this make sense to you now?
Yeah.
This is called implicit method. Implicit method, okay? Next one. We haven't finished. Oh, yeah, this is for part A. This is for part A. Part B. Part B, they ask you tangent, line tangent to the curve at this point. This point x, y value is given, right? So yeah, we are going to plug in, right?
Yeah.
Okay. So we are going to plug in to check how much is the y prime. So dy over dx equals negative x plus 1. X is negative 2, right? Plus 1. 2 times y cube. Y cube y is 1, right?
1 here.
Plus 1
So it goes
equals
1/4.
this is 1/4. Make sense? That's 1/4. That's right. So we got the slope. After we got the slope, we have this point. Can we do the point slope format, please? It pass -2 and 1. And we want to do the point slope format. Go ahead. Y minus 1 equals
Whoops,
slope
1 over,
times,
x plus 2.
yes, there you go. Does this make sense? So the physical meaning is this. Well, we don't know who is this guy. We really don't know who is this guy, but we can write down this in the implicit method. Yeah, this is that guy, right? And if we draw our line, say y minus 1 equals 1 over 4 times x plus 2. Did we mess up anything? Oh, here, I have a typo. That's not 8, that's 5, right? Yeah, I have a typo over here. Yeah, that's what's going on, right?
Yes.
The curve is like this. And without drawing, we should be able to write down the tangent line at a given point. We can do implicit method, plug in the xy value, we find this point, tangent line slope, and then use the point slope format, get this equation. And then we are able to write down this line. And we can verify this is a truly tangent line equation. Okay, which is perfect answer. This is for B. Okay, for the C. You can read this sentence, please.
C. Find the code. Find the coordinates.
The coordinates of the 2 points
on
on the
the
curve.
Where the line tangent to the curve is vertical.
Vertical. Yeah, we already see the graph. The graph is like that thing. And you want to get the tangent line vertical. That means you are these 2 lines on the left and the right edge. Okay. So what we will do, we can say our slope, if you want to have the vertical tangent line, then your slope has to be undefined. So you will make, you say y prime undefined at y cube plus 1 equals to 0. Okay. So y equals how much?
-1.
Y equals -1. And next, we will find the -1, plug in. Let's go ahead and plug in to find x value. X squared plus -1 to the power 4, right? And then -4, right?
Yeah.
Equals to 5. This is +1 -4 -3, yes? So this becomes x squared plus 2x minus 8, right? Cross multiplication. What's this?
+4 -2.
So x equals
-4 and 2.
So at x equals -4, y -1, or 2, -1. Does this make sense?
Mm-hmm.
As we can see here, -4, comma, -1. And the other guy, 2,
-4.
comma, -1. Okay,
Mm-hmm.
see, this is what's going on. Okay,
Okay.
very good. Okay, last one. Is it possible for this curve to have a horizontal tangent at points where it intersects the x-axis? So we want to find a horizontal tangent line. That means we want who? If we want to have a horizontal and tangent line, we want this guy to be 0, correct?
Mm-hmm.
Yes, so if we want to have horizontal tangent line, y prime u equals 0, that means x plus 1 equals to 0, x equals to -1, correct?
Mm-hmm.
And let's see, when x equals -1, we will plug in back into the original equation. -1 squared minus 2 plus y to the power of 4 plus 4y equals to 5, correct?
Mm-hmm.
So this becomes to y to the power of 4 plus 4y. And then minus 1 equals to 5. So this minus 6, right?
Mm-hmm.
Yeah, so let's see here. This guy, we can see if we y to the power 4 plus 4y minus 6, is this possible to equals to 0? Yeah, for this graph, actually there's, let's see there. Looks like the points around there, x equals -1, you know? And if we draw the line there, if we say x equals to -1, that position. And how do we find out the y value? Is that possible if we draw this? If we want to solve x to the power of 4 plus 4x minus 6. Okay, let me check this question and I go back to this question later, okay? Yeah. Next one, let's see over here. This is another equation and they want us to find the first derivative. And then with x equals 3, find the tangent line and then find the second derivative, okay? Let's do this one. Olivia, let's do this.
Okay.
Let's do the implicit method, go ahead.
Okay, so it's 2x plus 8y times dy over dx.
Equals
Equals 3y plus 3x times dy over dx.
okay. Next,
We can move one of them to the other side.
sure. So we do 2x minus 3y equals 3x minus 8y, right?
Yeah.
Times dy over dx. So dy over dx equals
2x minus 3y over 3x minus 8y.
okay, 2x minus 3y, 3x minus 8y. Students, even though this is same as this, but you still want to rewrite one more step, okay? Because some teacher, they are mean, so they take off your points, even though it's the same. Okay? So that's for the A part. Now for the B part, point P, x value, x coordinates of 3, at which the line tangent to the curve at P is horizontal. Let's find this. Let's plug in x equals to 3. Okay, 3 square equals 3 square plus 4y square equals 7 plus what?
3 times 3y.
3 times 9y, right?
Yeah.
Okay, so 4y square minus 9y plus 2, right?
Yeah.
And can we do the cross multiplication, or maybe you can tell me this is who? This is who?
Wait.
Four y minus 1 times y minus 2, right?
Yeah.
So y equals to 2 or 1/4, you know?
Mhm.
Okay. All right. So based on this x value, and we can find out the y value here is this, you know? And let's plug in those value into here to find if this dy over dx is 0, so that it's a tangent line, okay?
Okay.
Does that make sense?
Yes.
Let's plug in equals. When y is 2, x is how much?
3.
And then 8 times 2 minus 3 times 3, correct?
Yeah.
This equals 0, correct?
Yeah.
So this guy is a horizontal tangent line, yes?
Yeah.
And we want to check the other one. Go ahead, let's check. Three times
1/4.
minus
2 times 3.
2 times 3. This will not This is not equal 0, right?
Yeah.
So if this is not equal 0, then this is not the horizontal tangent line, right?
Yeah.
So this guy is not the answer. This one is the correct one. Makes sense?
Yeah.
Yeah. This one at x equals to 3, y equals to 2. We have a horizontal tangent line. Does this make sense now?
Yes.
One more step. We want to find the second derivative, okay?
Okay.
Let's try this one. This part is a little bit challenging, but I believe you can do it. D square y over dx square. This is this. This is d of dy over dx over dx. So basically, you are treating this guy as a new function, and you are doing this function's derivative. Okay?
Okay.
Does that make sense?
Yeah.
So we will do this guy. Derivative, okay?
Okay.
We will do this whole thing, this guy derivative, okay?
Okay.
Let's do the quotient rule.
Okay. So it would be
Mhm.
3 times dy over dx minus
3, yeah. So the bottom one is always that guy square, right?
Yeah.
And we copy down the square guy first. I will do this here, just remind. Can you first see this?
the derivative of
U prime times
times
V.
v minus u times v prime.
Okay. Now this guy.
3 times dy over dx
Okay.
minus
Min-
2
Very good.
and then times 8y minus 3x.
The top one derivative times the bottom one. Minus
Minus 3y minus 2x times 8 times dy over dx minus 3.
minus this guy copy down times the other guy derivative. 8 times dy over dx minus 3. Correct?
Yeah.
Okay, very good. Other student, any question here? This is a composite function. It's a quotient format. You want to do this guy derivative. So the quotient rule kicks in first. This guy square, you copy down. And then you are going to do this guy derivative, which is here. Y is not x. Y derivative is dy over dx. 2x derivative is 2 times this guy copy down minus this guy copy down times this guy derivative. So far, so good. Now let's do this distribution, okay? It looks complicated, but I believe that's those questions the school teacher taught her students, you know. Now let's do it. Go ahead.
Okay, so 24 y times dy.
Sure. Y times dy over dx.
And then minus
Minus 9x dy
minus
over dx.
oh
Correct?
yeah.
And then minus
minus 16y
plus
x.
x. Let's do there and there. Go, please.
Minus 24y dy over dx.
And then
Minus 9y. Minus 16x dy over times dy over dx. And
And
then
then
x.
plus 6x, right?
Yeah.
I say, oh my gosh, this is so ugly. But it's okay. Somebody will be gone. Did you notice that somebody will be gone? Who is that guy?
24y.
Correct?
Yeah.
Who else?
Um, 6x.
Yes. Is this more beautiful now?
Yeah.
Nobody likes those ugly expressions. Okay. Yeah, we like those simple expressions. Let's combine the like terms. Who is the like terms? This is the same, right?
Yeah.
Negative 9x, negative 16x, and minus. So what we should put here?
Negative 9x plus 16x.
Equals 7x, right?
Yeah.
Times dy over dx. Who else do we combine?
Negative 16y plus 9y
Equals
negative 7.
all right. Have we finished all the top?
Yeah.
Dy over dx is who?
3y minus 2x over.
Yeah, the last step. So we can plug in dy over dx. Dy over dx is this guy. So we can copy and we will replace, okay. So I'm going to do this. Times this whole thing. Okay, so far so good.
Yeah.
And then we are going to times this thing. for both top and also bottom, okay? So
Okay.
we are going to times make sense?
Yeah.
So this equals this guy and this guy cancel, right?
Mm-hmm.
So this
So-
is mhm.
7x times 3y minus 2x.
So that's 21xy minus 14x squared, correct?
Yeah.
And then minus
7y times 8y minus 3x.
56y squared plus 21xy over 8y minus 3x squared and then cube, right?
Yeah.
Okay, and then we can do one more last step to simplify. Okay, so this becomes to 42xy, right?
Yeah.
That's it. Makes sense now?
Yes.
Okay. If they ask us the value and what's the value, we can do plug in. The value we find here is x equals 3, y equals 2, and then we can plug in x equals 3, y equals 2, plug in to find out this expression value, okay? Does this make sense now?
Yes.
Okay. Yeah, students, so right now this thing, because it is, look, this is a College Board AP Calculus BC test. And this is those free response questions. So for sure, those questions are not going to be easy, okay? It's going to be challenge questions. And let's do another one. Look at this. They ask us to find the limits, We are going to do this by the derivative method. I first show the example of number one, okay? Number one. If I make my fx equals to 5x squared, f prime x is defined by this. F prime x is defined by this. So this is this guy. So it's asking for fx derivative. Fx derivative is 10x. So this answer is 10x. Now, Angela, look at number two. Tell me what you want to do for this one.
Is fx for this one tan 3x?
So fx is who?
Tan 3x.
Tan 3x. So this guy is
It's going to be secant squared times 3x.
secant squared 3x times
3.
3. There you go. That's answer. Okay, that's answer.
So you just
You
look
do
at
one more?
the right one, right?
Huh?
You just look at the f of x and you do.
Yes, you're looking for the fx. These two are not hard yet. Let's see.
Okay.
You do one more. Number 3.
Is it?
Yeah. The difference between this question and this question is here you don't have an x. The x was replaced by this. You see what I mean? So if you
10 pi over 4.
look, if I rewrite this number 3, if I rewrite this, okay? If I rewrite this, correct?
Mm-hmm.
And because, look, tangent pi over 4 is who?
Is 1.
Is 1. So this guy is asking for tangent x derivative at x equals pi over 4. Does this make sense?
Am I allowed to just write, are you allowed to write just tangent pi over 4 derivative or no?
No, you cannot write down this way. You cannot say tangent pi over 4 derivative. No. Tangent pi over 4 is a constant. Then constant derivative will be 0. You cannot write down that way.
Okay.
You can write down tangent x parenthesis derivative straight bar at location x equals to pi over 4. You have to write down this format. If you do this, the teacher will give you 0 points here because the physical meaning are different.
Okay.
The definition of this guy is saying you have function, which is a tangent x derivative at x equals to pi over 4. Because if you rewrite, this is 10x plus h minus 10x over h limit h approach to 0. This guy equals to 10x derivative. Because tangent pi over 4 equals to 1, pi over 4. So this is saying x equals to pi over 4. Okay?
Okay.
And tangent x derivative is secant square, you know?
Mm-hmm.
Right. It's secant square. So you do secant square x and x equals to pi over 4. Now you can plug in this guy into here. You cannot put this guy at this position. No, you have to keep this. When this guy does not have a derivative anymore, you can replace this into here. That's okay. You understand now?
Yeah.
Especially for those kind of very picky teachers, you have to watch out. Okay?
Okay.
Now, Emily, look at number 4. What do you think this guy's fx is who?
X to the power 6.
Very good, x to the power 6. Who is this guy?
2? No. 2?
2 to the power 6.
Yeah.
So this guy is asking you for x to the power 6 derivative at x equals,
2.
which is
6 times x to the 5th, which is
makes sense now?
yeah.
Okay. Like this, correct?
Mhm.
Okay, very good. Well, that's for those kind of questions. Using definition of derivative, and then using the power rule or chain rule or trigonometry rule to find out those limits. Okay. Now, see here. This one. If a function is differentiable, then f prime can be given by which one? This is the first definition for a derivative. This is another definition. This one, oh, no way. You even didn't see h approach to 0. This guy will not equals to anything, This is something crazy. So the answer is 1 and 2, okay? Make sense? Let's also do another one. Some of those questions looks very complicated. Let's see. Let's see number 10. Okay, yeah. Many of the questions here are from those real AP calculus BC test. That's why those questions looks really long. Okay. Who want to do this question with me? Is there any volunteer? No people? Angela, you want to give a try?
Okay.
Yeah, let's do the second derivative.
Oh, okay. So you the product rule, right?
When we write down this second derivative, we have to write down very neat. If you write down this by this, your teacher might take off all your points. Not this way. That's wrong. This is a correct way. Okay.
Okay.
This is saying you are treating you're doing the derivative. Okay.
Mm-hmm.
What we do here, we copy down, right?
Yeah.
Yeah. So I'm going to I don't want to do the product rule. I just
you want to times it out.
Yeah, I want to do the distribution.
So it's 6y squared minus 2xy squared.
There you go. Equals
12y times dy over dx.
12y times dy over dx minus 2 times
Minus 2 times y. I mean, no, 2 times 2y. No, y squared, sorry. Y squared.
X derivative is 1 times y squared plus
x times 2y times dy over dx.
There you go. Okay.
Mm-hmm.
Next.
You can distribute.
We will hold on plug in after we do the combination. Okay. All right. Yeah, let's do that later. Negative 2y squared plus we do 12y minus
x times 2y. Or minus 2 times x, 2y.
So 4xy. Correct?
Yeah.
4xy times dy over dx, right?
Yeah.
Okay. Hey, students, you do this way or you do this way, that's fine. Okay. But your square position has to be on the correct spots. And I did explain before, dy over dx square. This is just saying you are doing your first derivative times itself. Does this guy equals this guy? Angela? Do they equal?
No.
No, they never ever equal. This is your first derivative itself, parentheses square. This is the derivative of your first derivative, which is your second derivative. if you have a distance, ds over dt is your velocity, okay? So first derivative square is your velocity square, but your second derivative, which is this, who is this? This is dv over dt. dv over dt is your acceleration. Acceleration and the velocity square, they are not equal. Their physical meaning are totally off. They are not equal. This guy unit is what? Meter per second square. This guy unit is what? Is meter per second square. Okay. Now let's continue. This guy there.
So it's negative 2y squared plus 12y minus 4xy times y squared times x minus 2x.
Okay. So far so good.
Yeah.
Yeah. And we can combine the like terms. And actually there's not really like terms. And they ask evaluate. So we will plug in. Okay.
Okay.
So x equals to 3, y equals to 1/4, and then we can plug in to find out. Okay, yeah, I'm not going to use time to do it because I want to still teach students the relative rates. Okay, all right, I think that's those hard questions on this worksheets. Last stuff, I need to talk about relative rates. I'm going to pick those questions that students have trouble the most, okay? I know that that guy, this guy here, yes, asking this tip of the shadow and the length of the shadow, okay? Olivia, let's do number 5, okay?
Okay.
Go ahead. You can go ahead and read the question.
A man 6 feet tall walks at a rate of 5 feet per second away from a light that is 15 feet above the ground. When he is 10 feet from the base of the light, at what rate is the tip of his shadow moving? And at what rate is the length of his shadow changing?
But this question sounds very confusing. Let's draw this one, okay? So that's the light. The light is over here, okay? So I'm going to draw a yellow light. So this is a yellow light over here. And the guy is this pink one, okay? This pink guy is moving from here to here, okay? This guy is moving. So at this position, when this pink guy on here, the tip of the shadow is here. When this pink guy move to here, the tip of the shadow is here, okay? So basically, if we want to solve A, we are solving that guy's rate of change. Does this make sense to you, Olivia?
Yeah.
So the hard question for this here, the hard part for this question here is not the formula, not the derivative part, is for understanding this is who, this is who, and this is who, okay? Let me see this one more time. This is a guy, the pink bar is moving. This pink bar move from here to there, to there, to there, okay? This guy can keep moving. The tip of the shadow, if the person is here, the tip is here, If the guy is here, the tip is here. So if you draw a triangle by connecting the light and your head, that's your shadow's tip. If you feel this question really confusing, walk at night, okay? And you can choose a light and you can watch your tip of your shadow, okay? If you're there, your tip shadow is there. If you are here, your tip shadow is here. If you are here, your tip shadow is here. So your tip is formed by connecting this. Okay, that's your tip. And what's this? What's this? Look, if I say this is x, Olivia, dx over dt equals to how much based on reading this?
5
5 feet per second.
Per-
Does that make sense?
Yeah.
Right. Dx over dt is 5 feet per second. That's a thing we need to write down. Okay. Now we know that we take care of the first part. And the light is 15 feet above. The light is 15 feet above. This is 15. So far, so good.
Yes.
You draw this one. 15 is a fixed one. The person's height won't change either. Even you are here, you are still 6. You are here, you are still 6. But when you connect this guy and this guy, these two triangles are
Similar.
similar. Yes, similar. If it's similar, what's the proportion?
15 over y
Yes,
equals 6 over y minus x.
yes. 15 over 6 equals to y over y minus x. There you go. So tip of the shadow moving. Your tip is this y. If you are asking this, this is asking you dy over dt. Does this make sense?
Yeah.
This is asking for dy over dt. So we have this proportion. Okay. We have this proportion. 6, so I can also say y minus x over y equals 6 over 15. Cancelled 2 and 5, right?
Yeah.
So let's do the cross multiplication. 5y minus 5x equals to 2y, correct?
Yeah.
Then 3y equals to 5x, correct?
Yes.
And if 3y equals 5x, let's do the relative rates on both sides. 3 times dy over dt equals to 5 times dx over dt. Does this make sense?
Yeah.
Given dx over dt is 5. So dy over dt will be This is 5. So 5 times 5 is 25. Divide by 3. Does this make sense now?
Yes.
Next. They ask you the rate, at what rate is the length of the shadow? How long is your shadow?
Y minus X.
That part. Okay. You walk, this is you, this is the light. This is your shadow. The purple guy is a shadow. So basically, given dx over dt, you want to find this shadow, y minus x. So if I make shadow, I call shadow as s. S is y minus x. So I want to get ds over dt. This equals
dy over dt minus dx over dt.
dy over dt is
25 over 3.
the other guy is
5.
this is
10 over 3.
there you go. Does this make sense now?
Yes.
The question here, the hard part, look, those calculations compare with what we did early, compare with those things, it's nothing. Yeah, compare with what we did over here. It's nothing, but it gives trouble for a lot of students, not because you cannot do the math part, just because you don't know what this question is asking. Okay, so I want everybody to relook at my graph. If you have question, please ask me. Or you want to challenge yourself, you say, want to truly understand this. So today, after finish this class, walk outside with your mom and observe. Okay, find a pole, and then you start from this position. Your tip here at this position is this. And you move into here, and your tip becomes to here. Then you keep moving to here. Now when you move to here, this is your tip of the shadow. So if they ask you the rate of the tip of the shadow, basically you are asking these guys, this whole thing is relative rates. They always give you this guy, dx over dt, okay? But the question can change. Students, when we learn something, we want to truly understand. When we see this question, if I change the question, if I say, hey, I walk outside at night and I observe that my tip of my shadow is moving, okay? My tip of my shadow is moving at a rate of this. Then how much is my rate of walking? Your look, your tip, your shadow, and your real moving speed are totally different. This guy is not as big as this guy. This rate will be bigger than this guy because that's your shadow. It's projection from here to here, okay? So this dy and dy over dt and dx over dt there is a relationship. What's that relationship? By this equation, by triangle similarity. Okay. So that's your tip of your shadow. This is your tip of your shadow. This is the guys, the pink guy, the pink bars walking rate. That guy is your length of the shadow. What's the relation between here? dx over dt plus d shadow over dt equals to dy over dt. Okay? Does this make sense for everyone now? Any question are welcome here, okay? No question? Okay, we still have few minutes. So I'm going to say here, look, they do sometimes ask you this. The guy is standing here. Observe a flag, okay, being lowered. So this flag is going down. This distance won't change. dy over dt is changing. Dy over dt is at a rate of 5 feet per second. They ask you this angle. So you have tangent alpha. Tangent alpha equals to y over 25. Tangent alpha equals to y over 25. And if you want to find your angles related rates, you do your chain rule. This guy, derivative, secant square times d alpha over dt equals to 1 over 25 times dy over dt. Okay. Now you want to find this guy. How do you find that? They ask you, determine the rate at which the angle of the elevation is changing at the instant that the flag is 25 feet above. So 25 feet above. That means alpha equals to pi over 4. This is an isosceles right triangle. Alpha equals to pi over 4. Secant alpha is going to be secant pi over 4 is square root 2. That guy square is 2. So this guy will be this guy times dy over dt is 5. But this is going down, so you should put a negative. Dy over dt is 5, negative 5. And then negative 25 over 2, so negative 1 over 50. This is negative 1 over 10. Okay, that's how you find this. Yeah, I think other questions should be fine. Those conics, as long as you write down this kind of proportion and you change R to be somebody times H, and then you plug in, you can do this. You shouldn't have problem for here. Okay, I'm going to upload the video and upload the notes. Okay, that's for today's class. I'll see you next week.